Hello, this is Alan Fulton, Irrigation and Water Resources Advisor with the University of California Cooperative Extension, working in the northern Sacramento Valley of Tehama, Glenn, Colusa, and Shasta counties. Welcome to this tutorial. I'm following up on the previous tutorials related to the water budget and how it relates to soil moisture monitoring. In this tutorial, we'd like to discuss the pairing of water budget information in guiding your irrigation management decisions along with using soil moisture monitoring. In this tutorial, I'll provide you with 3 case studies that looks at the outcomes of the water budget and how it relates and compares to the outcomes of the soil moisture monitoring. I hope from these case studies, it will show you how they can each complement each other and help to validate one another, and that you will consider possibly using both. Okay, the first case study involves a second leaf almond orchard. It's data from last year in the 2019 season. On the left-hand side is a picture of the orchard, second leaf, in May of 2019. Right-hand picture is later in early fall, September of 26 of last year. You can see how the trees have progressed over the season. This graphic on the left shows a summary of the water budget information for the season and the seasonal trends. The red line with the red squares is the cumulative ET based on our weekly crop ET reports and adjusting for crop canopy size. The blue line is measured applied water plus rainfall that occurred after leaf out on March 1. As you study these trend lines, you'll see that the cumulative ET for the second leaf orchard was estimated to be around 26 inches of water, while the applied water was just over 20, almost 21 inches, leaving a gap between ET and applied water of about 5 inches, and raising the question, how was this water demand supplied? On the right-hand side are the soil moisture trends measured with a neutron hydroprobe. I measured to a depth of 7 feet in 1-foot increments. The navy blue, the pink, and the bright yellow represent the top 3 feet of soil in 1-foot increments. And the other colors, the light blue and the darker tones, represent the deeper subsoils. So right off the bat, we notice a separation in water holding capacity in the top 3 foot of soil versus the subsoil. It appears in this particular instance, the surface soils are lighter textured and hold less water than the deeper soils. The other thing we'll see here is that in general, in the top 3 feet, the volumetric water content was on the order of 1.7 to 2 inches in the spring, and it dropped to near 1 inch by fall, indicating somewhere on the order of 0.7 to 1 inch of soil moisture depletion in those 3 feet of soil. That 3 inch of depletion of soil storage contributed towards covering the gap between the applied water, rainfall, and the estimated ET. Looking at the subsoils, we did not see too much change from spring to fall, which might be indicative of the younger orchard and roots not yet being established, or that the soils were too wet and the roots simply couldn't get established. Nonetheless, we can see by adding in the soil moisture depletion from spring to fall, we close the gap, and the water budget begins to make even more sense as the crop ET and the accounting of the total water supplied is approximately equal. Overall, there was generally good agreement between the water budget information and the soil moisture monitoring information, and they validated each other. This could raise the question if you need to do both, or it could bring forward the point that it's 2 good indicators that agree and should give you confidence in your management decisions. Here's a case study from a third leaf almond orchard. Again, picture on the left is taken May 1st of 2019. Picture on the right, mid-September of 2017. You can see the progression that the orchard made over the season. This graphic on the left summarizes the water budget information. You can see our estimate of crop ET was 35 inches after adjusting for crop canopy size. And you can see that our measure of applied water and rainfall from March 1st forward was on the order of about 23 inches. So this brings to light a large gap of 12 inches between our estimate of crop ET demand and of the water supplied from irrigation and rainfall after leaf out. In this orchard, we monitored to a depth of 8 feet, again with a neutron hydroprobe in 1 foot increments. And you can see the navy blue, pink, and yellow are our most shallow 3 feet of soil represent. And then you can see the other, the light blue is the 4th foot, and then the darker tones were the deeper 5 through 8 foot depths. In this case, you can see trends in all soil depths from spring to fall, a decline in soil moisture. So there was a heavy extraction of stored soil moisture in this third leaf orchard over the course of the 2019 season. Each depth, it appears, contributed somewhere on the order of 1 1/4 to 1 1/2 inches of stored water in the surface 1 to 3 feet. Not quite as much in the deeper depths, but again, a good 1 to 1 1/4 inches of water per foot soil depth extraction. You add up these 8 depths at 1 to 1 1/2 inches, and you begin to see that it covered pretty much the gap between applied water rainfall and our estimate of crop ET. So again, we see pretty good agreement between our water budget approach and our soil moisture monitoring, making the case that they validate each other and can increase our confidence in what we're seeing going on in the orchard, and that things appear to be pretty good on target, and we would know what we might expect should we add more water. This is a third case study dating back to 2016. It's a mature Chandler walnut orchard in the Los Molinos area. Here's a picture of the orchard on April 8th as it's leafing out. Here's an orchard picture mid-September, about a month before harvest. On the left is the water budget data. On the right is the soil moisture data. This dark purple line is our estimate of crop ET for the season from April through October, about 42 inches. We monitored the applied water and rainfall after leaf out and accounted for about 34 inches of water applied or supplied to the orchard, leaving us a gap of about 8 to 9 inches of water between ET and that supplied. Looking at the soil moisture trends, again, measured weekly with a neutron hydroprobe to a depth of 9 feet, we see evidence of soil moisture extraction at every depth, and each depth from spring around April to late October decline from on the order of about 2 inches per foot. So we can easily begin to account for water from storage in the root zone of this orchard, and a deep root zone at that would cover the gap between the applied water with irrigation and from rainfall, and that estimated to be used through evapotranspiration. So again, in this third case study, we see good agreement between the two approaches, the water budget and soil moisture monitoring, and we can see how they bring validation to each other to help, again, give us confidence in the irrigation decisions that we're making with respect to timing and the amount of water that we put on. Thank you for joining me on this short tutorial. I hope it provides you some useful examples of how you can use a water budget, relating it to soils and validating it with soil moisture monitoring, or vice versa, validating the soil moisture monitoring with a water budget. I hope this encourages you to think about using our weekly crop ET reports in this fashion. Thank you.